you all. Welcome to grade 10 CBSE mathematics class. I am Sudhi here. Today we are going to discuss about chapter probability. So when you heard the term probability, you already studied the term probability and the chapter probability in standard 9. As you all know that, what is mean by probability? Probability means chance. It's the statement probability means chance. So it's simply chance. Probability means chance. So I will just say an example like when we toss a coin, it may or may not be head, or otherwise we can say that it may or may not be tail. That means there is a possibility of winning tail or losing head, and in other ways we can say that there is a probability of winning tail and losing head, vice versa, whatever it is, vice versa. So the thing is that when a toss is coin, when a toss is coin, there is a chance of tail and head. That is simply a chance. That chance is simply called a probability. What is the chance of getting tail? So when we toss a coin, or otherwise we simply know that, as you all know about cricket, at the beginning of cricket, every cricket match, there is a toss happening. And that toss, there is a chance of winning tail or chance of winning head. So when we toss a coin, there is a probability of getting head and or probability of getting tail. So simply we can ask you that, what is the probability of getting tail when we toss a coin? So in case, if we toss a coin, there is a chance of winning tail and winning head. There will be no other chances. It is either tail or head. So what is the chance of getting tail? It is 50%. What is the chance of getting head? It is also 50%. That means the probability of getting tail is 0.5 and the probability of getting head is 0.5. So 0.5 means 50% chance a head appear and 50% chance a tail appear. So when we toss a coin, there is a chance of getting tail and there is a chance of getting head, and that is the only two chances, on therefore the probability of getting a tail and the probability of getting a head is 50%. So when we adding those two events, we get 100%, that is 0.5 plus 0.5 is 1. So the total probability is 1. There will be two events. There may or may not be happen. And that two events, 50% plus 50%, that is 0.5 plus 0.5, and the total probability is 1. Either we get the tail or we get the head. And there is also another thing in such a way that if today is Sunday and I tell you that tomorrow is Thursday, is it possible? No, we all know that it is not possible. If today is Sunday, then tomorrow is Monday. But I say that if today is Sunday and tomorrow is Thursday, it is not possible. There is no probability of occurring Thursday tomorrow. Therefore, the probability is 0, which means that it is an impossible event. That event must not be happened. So the probability of getting a chance, or otherwise we can say that the chance of getting tomorrow a Thursday is 0. That means the probability of getting that event is 0. So I also say that if today is Sunday and I say that tomorrow is Monday, as you all know that is sure. So the probability of getting Monday tomorrow is 100%. That type of event is called a sure event, because that must happen. In the first case, that must not be happen, and it will not be possible such that tomorrow is Thursday. That means that the probability is 0. That type of event is called an impossible event. It will never ever happen. But in the case of sure event, the probability is 100%. That means that the probability is 1. So the probability value varies from 0 to 1, or otherwise we can say that 0 to 100%. The maximum percentage is 100%, or otherwise if we write in the case of probability, the maximum probability is 1 and the minimum probability is 0. So the value of probability lies between 0 and 1. Lies between 0 and 1. What is the probability of hitting a 6 in the next ball in a cricket match? There is chance. There is chance. That chance is called a probability. That chance varies with the different kinds of batsmen. If it is a hard hitter, there is more probability to getting a 6 in the next ball. If he is a bowler who is in the crease, then there is no chance. No chance. There is a less chance to hit a 6. That's simply a probability. The probability of getting 6 is there, but there will be less probability to hit a 6 if a bowler is there in the crease. But if a hard hitter batsman is in the crease, the probability of getting a 6 in the next ball is high. So that chance is simply called probability. So in the case of a football match, if the football match is between Brazil and any other non-playing football country, like otherwise we can say that Sri Lanka. If a football match between Brazil and Sri Lanka, what is the chance of winning Brazil? The probability is high because Brazil is a contemporary footballing nation and Sri Lanka is not playing football very well. So we can say that the probability of winning Brazil is high as compared to the probability of winning Sri Lanka. So there is a probability of winning Sri Lanka is there. There is a chance to win, but the probability is high on Brazil side, according to the stat. So if we considering the stat and analyze it and measure the probability, then we can write the mathematical expression of probability. So we are moving to the mathematical expressions in the case of probability. We want to discuss some problems. We will discuss the problems later. Right now, the value of probability varies from 0 to 1. That is must. The value of probability varies from 0 to 1, or otherwise we can say that if it is mentioned in percentage, the value of probability varies from 1% to 100%. So it lies between 1% and 100%, or otherwise we can say 0% and 100%, not 1% and 100%, 0% and 100%. And the probability, if it is not in percentage, it is simply 0 to 1. So there is something like that. Probability of an event D plus probability of an event no T. That means that probability of an event should happen and should not happen. So the maximum probability is 1. So the probability of an event D plus probability of an event no T is simply, as we know that it is 1. So what is the probability of an event E from this equation? Probability of an event E is equal to 1 minus probability of an event no T. Or otherwise, probability of an event no T equal 1 minus probability of an event E. So if we say that there will be two chances, probability of E, that is one event E and event no T, then we can say that probability of event E and probability of event no T equal to 1. Or otherwise we can say that probability of event E is equal to probability of event E equal to 1 minus probability of event no T. This is the thing. Next one, the probability of an event that cannot happen is. The probability of an event cannot happen is, as in the early example, if today is Sunday and I will say that tomorrow is Monday, that will not possible at any cost. That event is called an impossible event. The probability of an event that cannot happen is called an impossible event. Now the probability of an event certain to happen is, that is sure that event should happen. That is called a sure event. Probability of an event certain to happen is called a sure event. Sum of the probability of all the event, that means that there will be 1, 2, 3, 4, 5 elementary events are there, and the sum of the probability of all the elementary event is always 1. That is the maximum value of the probability is always 1. The probability of an event lies between, or it is less than, the probability of an event is less than 1 or greater than or equal to, less than or equal to 1. It is less than or equal to 1 or greater than or equal to 0. So the probability of an event is always less than or equal to 1. That means the maximum value of a probability is 1 and the minimum value is 0, or it is equal to or greater than or equal to 0. So how will you measure probability? How will you measure probability, or how will you find the equation of a probability? So if an event should happen, what is the probability there? That we want to discuss. I will just show the equation. I will just show the equation, and the problems we will discuss later. I will just show the equation. Right now, the probability equation is in such a way that the probability is denoted by P of E or P of S or like that. This is P of E, probability of E. So, events happened by total outcome. Simply explain in such a way that, so how will you find the probability? For such that, I will just show an example. If a coin is tossed, what is the probability of getting a tail? If a coin is tossed, what is the probability of getting a tail? So if a coin is tossed, there will be two chances only. There will be two chances only. One, we get a head, or otherwise we get a tail. So the total outcome is, if a coin is tossed, the total outcome equal to probability of getting a tail. Probability of getting a tail is, the chances of getting a tail is 1. So the probability of getting a tail is 1 by total outcome, that is 1 by 2, that is 0.5. Otherwise we can say that it is 50%. Probability of getting a head is, again, what is the probability there? There is a chance that head will appear. So the probability of getting a head outcome is 1 and the total outcome is 2. 1 by 2 equals 0.5, that is equal to, we can say that 50%. So one more example is that, if a die is thrown, as we all know that what are the numbers in the die? 1, 2, 3, 4, 5, 6. So if a die is thrown, what is the probability of getting 4? Probability of getting 4 equal, there is a chance 1 times 4 appear. So 1 by total outcome is 6. Probability of getting 2, that is again 1 by 6. Okay, what is the probability of getting a number greater than 4? What is the probability of getting a number greater than 4? Greater than 4, how many numbers are here? 5 and 6. So the outcome is 2. So the probability of getting a number greater than 4 equal, 5 and 6 are the numbers will appear and the outcome is 2 by the total outcome is 6. What is the probability of getting a number less than 4? Less than 4, there is 3 chances, 1, 2 and 3. So the probability of getting a number less than 3 is that the outcome is 3 by the total outcome is 6. That is 2 by 6 equal 1 by 3, 3 by 6 equal 1 by 2. 1. So this is the way of finding probability. This is the way of finding probability. So that's the method to find out probability, and right now we want to discuss out some problems regarding probability. Then it will be very clear how the probability problems will be solved. So we want to discuss some problems regarding probability. Now moving to the problems. Two dice are thrown at the same time. Two dice are thrown at the same time. As we all know that one die consists of 6 numbers from 1 to 6. Here, two dice are thrown at the same time. Two dice are thrown at same time. What is the probability of getting the same number on both dice and different number on both dice? So, what is the total outcome that we want to know? What is the total outcome? So two dice are thrown at same time. So what is the total outcome? The first outcome is we want to find out the total outcome. The first outcome is 1 1. That means that 1 1 is in the first die number 1 appears, second die also number 1 appears. Second one is 1 2. First die 1, second die 2. Then 1 3, 1 4, 1 5, 1 6. Completed. First pattern completed. Next pattern 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Second pattern completed. That means that in the first die number 2, second die number 1. First die 2, second die 2. First die 2, second die 3, like that. Next outcome is 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. Third pattern completed. Then 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. Fourth pattern completed. 5 1, 5 2, 5 3, 5 4, 5 5, 5 6. Then 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. All the outcomes are completed. So how many outcomes are that we want to discuss? How many outcomes are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So the total outcome is 36. Total outcome is 36. So I will write the answer here. Now, the same number on both sides. What is the probability of getting same number on both sides? How many same numbers appear? Here, 1, 1, same number. Then 2, 2, same number. 1, 1, same number, 2, 2. Then 3, 3, 4, 4, 5, 5, and 6, 6. So, same number on both dice, there is chance 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, 6, 6, 6. So there will be 6 chances. There will be 6 chances there. Same number on both sides appear. So what is the probability? Probability of getting same number on both dice equal. There will be 6 chances such that both dice same number appear by the total outcome. Total outcome is 36. So 6 by 36, that is 1 by 6. So the probability of getting same number on both sides is 1 by 6. That is 6 by 36, 1 by 6. Then the probability of getting different number on both dice equal. The probability of getting different number on both dice. So other than this one, other than this 6 one, all others are different. So there will be 30 chances are there. So the probability of getting different number on both dice is 30 by the total outcome is 36. That is 5 by 6. 5 by 6. When we add 1 by 6 plus 5 by 6, what we get? 1 by 6 plus 5 by 6 is 6 by 6, that is 1. 6 by 6, that is 1. So the total probability is 1. It's clear, the answer is correct. So moving to the next problem. Moving to the next problem. A bag contains a red ball, a blue ball, and a yellow ball. So how many balls are there? 3 balls are there. A total number of 3 balls are there in the bag. Kritika takes out a ball from the bag without looking into it. So she takes out a ball without looking into it, looking into the bag. So what is the probability that she takes out the yellow ball, red ball, and blue ball? So this is very simple, such that total outcome, that is the total number of balls. Total number of balls, that is total outcome equal 3. Probability of picking a yellow ball P of y is equal to only one yellow ball is there, so the outcome is 1 and the total outcome is 3. So the probability of picking a yellow ball is 1 by 3. Probability of picking a red ball, only one red ball is there, the total outcome is 3, so 1 by 3. Probability of picking a blue ball, that is equal to one blue ball is there and the total outcome is 3. So what is the total probability? Total probability equal 1 by 3 plus 1 by 3 plus 1 by 3, that is equal to 3 by 3. 3 by 3 is equal to 1. So this is the correct answer. So that's all about the two problems. We will do another problems in probability. So moving to the next problem. There is one card is drawn from a well-shuffled deck of 52 cards. Also, I already say that the card distribution we detailedly studied in the chapter 9, not chapter 9, standard 9. Standard 9 probability chapter, we already discussed the detailed distribution of card. There will be 26 black cards and 26 red cards are there. A total number of 52 cards are there. Again, the 26 red card is divided into 13 and 13. 26 black card is divided into 13 and 13. All the detailed distribution of card is studied in standard 9. So go through that chapter, probability in standard 9, and then only we can do the problem. So one card is drawn from a well shuffled deck of 52 cards and calculate the probability that the card will be an ace, a face card, red king getting a queen and not getting a queen. So first of all, how many total outcomes? That means how, not how many, how, what about the total outcomes of the card? Total outcome is 52, as we know. So the probability of getting an ace card is, probability of getting an ace card is, how many ace cards are there? 2 in red and 2 in black. So there will be total number of 4 ace cards are there. That is the probability is 4 by 52. That is 2 by 26. That is 1 by 13. The probability of getting an ace card is 1 by 13 because there will be 4 ace cards are there, 2 in red and 2 in black. That is total number of 4 ace cards. Second one is probability of getting a face card. How many face cards are there? 12 face cards are there. 6 in red and 6 in black. Queen, king and jack, or king, queen and jack are the face cards. How many face cards are there? In red there will be 6 face cards. In black there will be 6 face cards. That means a total number of 12 face cards are there. So the probability is 12 by 52. 12 by 52 is 6 by 26. 6 by 26 is 3 by 30. 3 by 30. The probability of getting a face card is 3 by 30. Question number 3. A red king. Probability of getting a red king. How many red kings are there? Total number of 4 kings are there. 2 in red and 2 in black. That means there will be 2 red kings are there. So the probability of getting a red king is 2 by 52. That is 1 by 26. Fourth one. The probability of getting a queen. Probability of getting a queen. Probability of getting a queen is how many queens are there? 2 in red and 2 in black. There will be 4 queens are there. The probability of getting a queen is 4 by 52. That is equal to 2 by 26. That is equal to 1 by 30. Probability of getting a queen is 1 by 30. The next one is probability of will not getting a queen. Probability of not getting a queen. It is simply how many queen cards are there? 4 queen cards are there. That means the remaining 48 are not queens. So the probability of not getting a queen is 48 by 52. That is equal to 24 by 26. That is equal to 12 by 13. 12 by 13. So this is the probability of getting, will not getting a queen here. So that's all about the car. So while doing this problem or before doing this problem, you please go through the chapter probability in standard 9. There we explain the distribution of cards in detail. So after carefully reading and studying the distribution of card, you can do the problem very easily. Okay. So the next problem is that an integer is chosen between 0 and 100. An integer is chosen between 0 and 100. It is not 0 to 100. It is 0 and 100. So between 0 and 100 means 0 and 100 are not included. 0 and 100 are not included. And the numbers starts from 1 and ends at 99. So the total outcome is total numbers is equal to total numbers or the outcome is equal to 99 only. So 1 is the starting number and 99 is the ending number, excluding 0 and 100, because the number is between 0 and 100. So we can't consider, we never ever consider 0 and 100. So the first one is that what is the probability of getting a number that is divisible by 7? Probability of getting a number divisible by 7. So what all the numbers are divisible by 7? 7 is divisible by 7. 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, 91 and 98. These are all the numbers divisible by 7. The next number is 105, but it is crossing 99 because the n number is 99. So it is not considered up to the number 98. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the probability of getting a number divisible by probability of getting a number divisible by 7 equal 14 by 99. First question is completed. Moving to the second question. The probability of getting a number divisible by 10. The probability of getting a number divisible by 10. Probability of getting a number divisible by 10. That is divisible by 10. How many numbers are there divisible by 10? 10 is divisible by 10. 20, 30, 40, 50, 60, 70, 80 and 90. 1, 2, 3, 4, 5, 6, 7, 8, 9. Total of 9 numbers are there. The next number is 100, which are not included. Therefore, we will take up to 90 only. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, the probability of getting a number divisible by 10 equal 9 by 99, that is equal to 1 by 11. 1 into 9, 9, 11 into 9, 90. 3. Probability of getting a number which is the multiple of 25. What all the numbers are the multiple of 25? 25, 50 and 75. So the probability of getting a number which is the multiple of 25 is equal to 1, 2, 3. 3 by 99, that is equal to 1 by 33. 1 into 3, 3. 33 into 3, 99. The next one is probability of getting a number which is a perfect square. What all the perfect squares are between 0 and 100? 1. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, and finally 10 square is 100, which are not included. Therefore, we have to take up to 81 only. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability of getting a number which is a perfect square equal 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 by the total outcome is 99, that is equal to 1 by 11. So that's all about the problem. Most probably these types of problems are included in the chapter probability. Before moving to the chapter probability in standard 10, you carefully learn the chapter probability in standard 9. Then you will be very easily to catch up with these chapters and problems regarding probability. This is a simple chapter probability and you can score maximum marks from probability chapter in the board exam. So this is a very simple chapter. As I earlier said, this is a very simple chapter. You can score maximum mark from the chapter probability, and this is all about probability and problems related to probability. These types of problems will be only asked in the board exam questions. So please prepare for the chapter probability, and that's all about the chapter probability. And thank you for joining me in the class, and we will see you in the next class with another chapter. And I am Sudhi here signing off. And thank you again. Thank you all. And best of luck for the board exam. Thank you everyone.